Imagine managing health insurance claims for millions of people across India, over 2,000 tables, 20 terabytes of live mission critical data, and an absolute zero tolerance policy for downtime. How do you migrate a legacy Oracle and land it safely on AWS Aurora Postgres without breaking a single transaction? A very warm welcome, everyone, to Mydbops My Webinar 53. Today, we are going behind the scenes of one of the largest database modernizations in India's healthcare sector. And we aren't just talking about theory, we are sharing real-world battle stories. Earlier this week, we ran a poll on LinkedIn asking database leaders and engineers a simple question. What is your biggest challenge when migrating from Oracle to Postgres? So take a look at what the community had to say on screen. 58% said PL/SQL logic conversion was their biggest headache. 28% pointed to application compatibility. 14% highlighted data migration and CDC setup, and 3% cited cutover planning and downtime management. So these numbers tell us a clear story. Moving off Oracle is not just about moving data, it is about handling logic rewrites and keeping applications stable. So in today's webinar, we are decoding these exact challenges. We will look at how the engineering team compressed a 35-hour data load down to just 4 hours, and how it handled complex logic rewrites and planned a safe 30-minute cutover window. So before we jump in, a quick word about Mydbops. Mydbops, it recently, Mydbops. So it recently crossed a major milestone of completing over 10 years in the database industry. And today our team supports more than 800 clients worldwide, providing round-the-clock 24/7 managed database services, performance consulting, and cloud migrations across MySQL, Postgres, Maria, MongoDB, TidyB, Cassandra, AWS. And a quick note on today's session. Today's webinar is being recorded, and we will email you the full recording and slide deck early next week. We have a dedicated Q&A session at the end. So please type your questions into the chat box at any time during the presentation. And to walk us through this journey, I'm delighted to introduce our speaker for today, Kabilesh PR. Kabilesh is a founding partner at Mydbops and brings over 13 years of hands-on database expertise across distributed SQL, MySQL, and Postgres. And he's a recognized speaker and blogger and was a very first certified TidyB professional in India. So over the years, Kabilesh has guided many enterprise teams through large-scale migrations and complex performance challenges. So it's our privilege to welcome him here. Kabilesh, over to you.
Thank you, Shani. Warm welcome to everyone. So let me share my screen. Just let me know once you see my screen. Can you see my screen? Yes. Shani, can you confirm if you can see my screen?
Yes, it is visible.
Okay. Thanks, guys. Thanks for joining. Let's get started. So our topic today will be, as Shani has already given a detailed introduction. So how we migrated, what are the challenges, what are the things we faced in this migration of from Oracle to Postgres. Basically, it is a modernization program under AWS. Okay. So this is about me. I have around 13 years of experience, and I'm the first TidyB certified professional in India. And I'm an active tech speaker and blogger, and I'm just new to Postgres. I'm just learning Postgres and practicing Postgres for last 2 years. Okay. So what we will cover throughout this webinar was what is the rationale behind migration. So what was the client engagement we did with respect to the planning, assessment, and what is the objective that was set, and also the migration scope. and what tools we evaluated and what tools we finalized as a part of this migration for the entire migration journey, and how did we do the execution and cutover, what are the planning done, and how the rollback window was set, what was the challenges. And at the end, I will also share some of the blockers, workaround things which we have done to pass on the migration or the changes as well. Okay. So what is the business reason behind migration? So this migration has become a very common thing, right? If you go to LinkedIn, you'll see a lot of people saying we have migrated from Oracle to Postgres or MS SQL to Postgres as a part of this modernization and multiple things, right? So what is the rationale behind this migration? The biggest thing is first is the cost optimization. Like as people are getting fed up with paying large amount of tables to the proprietary Oracle and MS SQL for even for a small features. Let's say in Oracle, when you have to create a, I'm not against Oracle, but if you have to use certain features, you have to pay extra on the licensing fees. So those are the major reason, that is cost optimization, and to avoid vendor locking. The next major reason is avoid to vendor locking, like depending completely on the Oracle features to develop features and application development. So it is just hindering and increasing. Again, it is coming back to the cost, right? When a new feature is being added, when you want to use a new feature, again you have to pay for the cost. So that is being a vendor lock-in, avoiding that. And also as a part of cloud movement, people are just moving towards Postgres. And also Postgres has a strong open source community, and also all the features, like most of the features in Postgres is available for free, and also with extension, the use case of Postgres is tremendous. You can do anything with respect to the Postgres along with the extension, and it also provides agility and flexibility for the development team to explore and more features with the flexibility that Postgres provides. So these are the major drivers for moving out from Oracle. So next, why Postgres? Because there are multiple databases in open source world, right? Why specifically Postgres? So Postgres fits into the architecture of Oracle. That means they share a common architecture in terms of multiple things like vals and major things like schema, the dialects. So Postgres being the natural fit for Oracle, and also enterprise grade capabilities. We just discussed it. So Postgres provides all the enterprise grade features like uh, means most of the enterprise features such as the means encryptions, JSON support, JSON B support. The multiple features are available with Postgres, and also it's a true open source. True open source in the sense, Postgres is not a entity oriented. It is a uh, free community software. That means, for example, MySQL, it is controlled by Oracle, but in case of Postgres, it is not. It is a uh, it's not a central entity one controller. So that is also a major reason for companies choosing Postgres, and reduce infrastructure dependency. Like Postgres can run on any hardware, but in case of Oracle, you have to have a dedicated uh, cluster or dedicated hardware kind of things to run the Oracle cluster, but not with Postgres. Postgres can even run with a Kubernetes system or in a Raspberry Pi as well. And cost optimization, obviously, which reduces the uh, cost by reducing the licensing cost, support cost, and multiple other things. Okay. So the next phase is the engagement. That means I'll just give a brief introduction about the customer. The customer is in health insurance platform. They are the number one in India, just handling the insurance product. They have multiple other products. In the insurance, they are the number one, like of hospitalization, uh, cashless payment, and multiple things. So this is a source on the target version which we will be moving. Like they had a Oracle 19C, which is running on a rack cluster. To say more on the rack, right, it's a two-node rack running on a 192 GB RAM and a dedicated hard disk. It is like 64 core machine. Two racks are there. And the target will be Aurora managed. That means it is a managed Aurora Postgres. And the database size, the actual database size is 20 terabit Oracle. What we plan to move was 4 terabyte of live data, that means 6 months of data from Oracle to Postgres, and the schemas. So we had around 2000 plus tables. across multiple schemas. And codes, like we had all the codes, views, procedures, triggers. So to say exactly, we had around 165 views and close to 300 procedures. Triggers were minimal, like 5 or 6 triggers. And the existing design, like, they were on track. In Aurora, it will be managed Aurora with a reader. And currently we have one writer and a four reader. That is a setup right now we have. And backup, obviously, they were using ARM and export, which is native to Oracle. And here we have the managed backup, like snapshots in Aurora. And monitoring, they used OEM. Here we are supporting them with a Mydbops managed monitoring solution. And also on top of that, we use CloudWatch as well as the performance metrics. Okay. So this will be the definition of source and target. So what are the 6 features that defines the success of this project? The first thing is functional compatibility. So client is not willing to compromise on the functionality. Like whatever the functionality which is currently running on Oracle should be ported to Postgres without any failure or compatibility misses. This is the first and foremost thing. And second is the data consistency. The 6 months of data, right? The count and the data should be apple to apple matched in the Postgres as well. And to reduce the downtime as much as possible, because they are the insurance platform. Usually the morning times and the insurance uh, filing can happen at any point in time, because it's a emergency kind of an emergency platform, right? So cashless can happen at any time. So they want to have a minimal downtime as much as possible, and performance stability. Post moving to Postgres, they want a stability. That means people should not complain saying that it was working in Oracle, why it is not working in Postgres, it is slow, or we are not getting those queries as fast as possible like Oracle. So these situations should be avoided. And operational readiness, like the DIA solution alerting, everything should be in place similar to Oracle. And also rollback safety. In case of there is a mismatch or in the last moment thing, they should be able to fail back to Oracle, like a reverse replication or CDC, something has to be managed. So these are the criteria that defines the success of this project. Okay. The next thing is the tooling and approach. Okay. So what are the toolings we evaluated? So these are the list of toolings. There are more toolings on enterprise, on paid version tools is available. So these are the tools we assessed as a part of this migration. Like we have assessment. So basically assessment in the phase, you just connect to the Oracle with your tool. Maybe we used AWS SCT to evaluate the complexity of the migration. Maybe the number of tables, the number of procedures, those complexity assessment is done. So you can also use Oracle PG, which is also an open source tool. And EDB also has a migration portal tool, which is obviously a paid tool. And next comes a schema conversion. That means the schema mapping from Oracle world to the Postgres, like the character to character, integer, float, and those mappings will be done. And I would also like to say one thing, like no tool is 100% perfect. So even by using these tools, right, like Oracle PG or AWS CT, there is always a manual intervention or manual review is needed, because tools, most of the times, they give a generic things, right, which is fit for a common use case, not for a specified use case. So it is always recommended to review the schema mapping, because schema mapping plays a very important role in the overall migration. And next is the procedure and functional conversion. So this is an important part, like uh, as it's a legacy system, right? So if you are working with Oracle and MS SQL, in those days, most of the application functionalities will be written into the database as functions like procedures and multiple codes. So this is the major part. Like we have to convert the same to the Postgres. And next is the data migration. We evaluated multiple tools. We landed into AWS DMS. I'll just say what is the reason. So data migration has two parts. One is like loading, and also it has to support the bulk loading glob object, that is the blob objects which is present in Oracle. The same has to be backported. So this loading, right? So you have to uh, evaluate a tool that supports bulk loading as well as the support for large objects, migrating from reading the blob objects and pushing it correctly. And next is a CDC, that is ongoing replication. With ongoing replication, we choose DMS, that is the best tool available right now. And the next is the Oracle Golden Gate, obviously, which is a paid tool. So you have to get an enterprise license. WCM, which is available in open source, you can also use that. That is also not a problem. Validation. So sorry. Uh, with the validation, DMS itself provides a complete validation. So what is a row count which is moved? The progress for each of the phase is visible at the DMS. And also you can have a custom script to validate the count between the source and destination. And there is also checksum tools which is also available. And the next is certain automations we have done on our own for a small, minor task, which is very negligible. Okay. So why we chose DMS? First obvious reason, this is a modernization which project which is funded by AWS. So obviously we had to use the DMS. This is one reason. And the other reason, as well, other important reason is, so DMS supports full load plus CDC. That means you can have a one-time full load, and also you can configure an ongoing replication with respect to the CDC. Okay. And also as it's a managed services, right? No headache at your end to manage an instance, application instance, nothing. It's all self-managed by the AWS itself. And also it provides a good tooling around the DMS, like monitoring, error handling, logs. Logs can be stored in S3 as well to view the historical logs, and scalable and flexible. Like whenever you feel there is a bottleneck at the instance, or you can upscale the instance online. That means the replication instance which is used for DMS can be scaled in minutes, and it fits a large migration. As AWS, it's a proven tool to have large scale migration done. You can read their case studies as well, and it is compatible with Oracle. It can read Oracle data and push it to the Postgres, and obviously it is integrated into the AWS ecosystem. And as we are moving towards Aurora Postgres. Okay. So next, we'll discuss about how we started this migration execution. The first thing, like, we had a detailed plan with the customer, like what were the objects and what are the splittings they are going to do in terms of application. So it's a big chunk of data. So I would recommend not to move the complete chunk in one shot, because the possibilities of error is very heavy. So we had a detailed call with the customer. So customer is also inclined to separate it as modules. So we had split it around 8 modules in total. Okay, so we split into 8 modules, and 8 modules had its own separate tables, and we managed it we time boxed everything. Like, what is the module which is going to be first, next module, what are the dependencies? So we segregated the table sitting along with the application team, and then map their dependencies. What are the dependencies on each of the modules mapped? And the first thing, we also flagged on the unsupported features. So they might be using some licensed feature, and we tried to have a workaround. Like, for example, they were using schedulers in Oracle. The equivalent of this in Postgres is we have the PG cron. So whatever is possible, we have a workaround and possible things. But there are certain things which is really unsupported, like the certain old level of code which they have written as application logic in the database set, that needs to be rewritten at the application layer. So we flag them up front, and we seek the help of application team to check them, and also we given a workaround as well, like this we can do, or this is a workaround, and that has to be incorporated in the application, right? So those were discussed. And complexity. So what are the complex things that needs to be migrated first? We had a clear cut plan before the actual migration began. So next, these are some of the Oracle to Postgres compatible schema mappings we did. Like numbers, obviously we have multiple numeric, integer, and begin. The one important thing is, when you are using SCT, that is schema conversion, it, as I said, right, it uses a generic thing. Okay, numeric, it uses numeric for both integer value as well as for a float value, right? So this, during our migration, we had an issue, like when the floating values were used as it's an insurance company, right? So they have values, the amount or the most of the amount calculation and values were in the float values. These float values were causing inconsistency, so we had to change those to float of it, that is uh, data type in the Postgres side to manage this. So these are some of the schema mappings and compatible details which we created as a part of this mapping. So next important thing is as I said, right, we had around multiple codes, of which views are the important thing. We had 165 views. Even some of the procedures they had deprecated upfront, but as it's a legacy Oracle code, right, so you can see the compatible things like there will be plus symbol at the the Oracle side, as it's an ITC version, they have not done any changes. So when you give the same dialect, that converts to left join in Postgres. So these kinds of changes and also the timestamp mapping differs between uh, Oracle and Postgres, and also certain uh, things on the Oracle, like the colas and the NVL has to be also mapped correctly with respect to the schema conversion. And also one more thing, even we tried, you can say like you can use the AI to convert these schemas and conversion. Even we tried the AI, but this legacy code, right, it was not properly converted. Or when we ran the code onto the Postgres site, it was giving a different result set comparing to Oracle. So again, we had to manually rewrite the code with the compliance to match the Oracle pattern or the expected result set comparing with the Oracle. So these are some of the things we did with respect to the loading. So first we got the tables with respect to each module. On the each module, the tables were grouped based upon the sizes as well as the blob tables, that is tables with large object, and tables with static tables as well as a transaction table. The static table is a kind of one load activity. That means it may be a config table, like you can do a one-time load, and after that there will not be any frequent changes to the table. And dynamic table, it's like it is created on the fly. So these tables we had removed from the migration. We did a one-time CSV loading. And for the other transaction tables, we segregated them based upon the LOB size. Like always go with limited LOB size while we are creating the DMS task, because when you do a full LOB, right, the time to load increases. Okay, and also try to get a LOB size from the Oracle side. So during this entire project, we did not have a direct access to Oracle. So we had an intermediate team who manages the Oracle database. So we give their queries, give our queries to them to get the LOB size for each tables. They share it in a CSV, and from the LOB size, that is we get a size, and we define the same size in the DMS task with 30% buffer to accommodate if there is any new change, because Oracle handles LOB differently comparing to Postgres. So we had a 30% buffer size. And during the loading, we had also disabled the foreign keys at the destination side, that is our Aurora side, so that the loading becomes faster. And also later in the stage, we created the foreign keys. And in certain places, when we had a larger table with huge amount of data, we had a table where we had 200 billion of records. So those tables, we had disabled the indexes and we recreated them in the Aurora side later post the loading. And these are the best practices for to keep your DMS active and to get fastnet. And also I will share some of the other workarounds as well later in the piece. And CDC for the ongoing replication, right? So to have the CDC enabled via DMS, the first major thing is you need to have a primary key for all the tables in Oracle. If primary key is not available, there is an option that we need to enable a unconditional supplemental login at a table level. You can do it at a table level, or also you can do it at a database level in Oracle side. And the next important thing is to have enough archival logs. See, for example, when the full load completes, let's say if a table is around 200 GB of size, for load 200 GB of size, it might take certain amount of time. Let's say 3 hours or 4 hours based upon the multiple factors like the destination, source, and the throughput and multiple things. So you have to retain the archive logs in such a way that after the bulk loading, you should be able to start the incremental load. If the archive logs expire or you do not have a archive log is nothing but a val logs in terms of Postgres, and it's archive log in Oracle. So when you don't have it, the CDC fails. Then again, we have to do a reload and we have to start from the fresh. So uh, ensure that you have enough archive log and you have enough disk at the source side to hold this archive log. So before you move on, right? So we had done all the things, right? We have made the schema mapping, we have made the conversion with respect to the code. We Before moving on to the actual production migration, we did a load test onto the sorry, not a load test, we dumped the data into a UAT environment, and team, that is application team, they performed a complete load test to ensure that the performance is uh, means not breaching the threshold level with respect to application and certified. This is an important step in migration. Everyone should abide to this because after moving to the production, this will avoid surprises on the uh, Aurora side, right? And you will not hear much of things like it was working in Oracle, it was not in Postgres. Those things you will not hear when you do this step, when you have a clear-cut idea, code functionality validating, and the Lotus performance. And these are the major best practices which we did. I have already also discussed. We disabled the foreign keys or we dropped the foreign keys at the Postgres side to fasten the loading. And we referenced and we had the master and the reference table, right? So we were unblocked and load the transaction table. We loaded the high transaction table in a different batches. Let's say if the table is highly transactional and it's very heavy in size, we created a separate DMS task, a single DMS task for a single table. If the table is very heavy in operation and highly transactional, so we created multiple tasks similar to that. And LOB, we got a specific LOB size from the Oracle side. We added 30% buffer and created the limited LOB size on the DMS task, and we started the loading by chunking and batching. I'll explain what is the chunking and batching we have done. And we recreated the index later. And we had enables and we enable the foreign keys once the CDC starts. Like we post the full loading, you can pass the DMS task in the CDC phase, and you can do your activity and resume the CDC task. It is possible. And we did an analyze table to refresh the statistics with respect to Postgres. And during the time of cutover, like we had a random sampling, like 3 months of some range of data we took from Oracle, and we validated the count with respect to sample data. So how we planned the cutover and rollback. Okay. So this is the production go live plan which we have given. So at the so cutover date was finalized. So during the window time, right before the start of window time, so they will start stopping the application. So that point is called the freeze time. There is no write happens. Application completely stops at both the side, both at the source and destination side, and there is no writes happening. It's a complete downtime window for them. In this 15 to this time, the freeze window will ensure that the in-flight data, that is CDC, is asynchronous. So asynchronous in the sense it has to read the data, get it to the DMS instance, and then apply back to the target side, Aurora side. So we gave 15 minutes to 10 minutes of time to the in-flight data to sync. So that is the final delta sync. Once the delta sync is completed, we ran our scripts to validate the count between the source Oracle and the destination. So in certain cases, we have also faced the issue here in the destination side with the DMS. Some tables were mismatched. There was some mismatch of like 200 to 100 record. For smaller tables, what the approach we followed was we reloaded the table within that window. We were able to do that. For a larger table, if the issue was done, in certain cases, we have done failback. That means we have not gone with the proceeded with the migration. We stopped the migration there and we had rolled back, and then we corrected the table issue, and then we did the thing. Okay, so this is the important part of data validation during the window time and sequence. So we got the final sequence from the Oracle with respect to the sequence column, and we added some buffer of like 1,000 to 10,000 based upon the table size to know exactly where the Postgres writes have started and Oracle writes have ended. In this way, this will help in the rollback situation as well. So post this, if there is any after a production live, if there is a rollback initiated from the application side, we know that from this particular sequence, it is from Postgres side. So this needs to be replayed. So that is also an important thing. So we had the sequence reset done during the cutover window. And also obviously it's a config switch, like we had a DNS mapping. These are all the DevOps team handled things. So DNS mapping was done. And we started the application at map to Postgres. And we started monitoring for some time. Like the monitoring window usually is the regressive monitoring window is done immediately after like first 1 hour. They did a smoke testing, application validation, everything, and post the go live application was allowed, right? The public traffic, that is the live traffic, gets into the system, and rigorous traffic and traffic monitoring was done for 2 hours to make sure that the live traffic is not affected. Logs were monitored, everything was done, and then we certify it. And next 24 hours, like there will be a means emergency kind of monitoring where we assign a dedicated person to just completely to look over the Postgres side. On the Postgres side, for a safer window, we have added more replicas, right? To initially we planned for four for the cutover. We had added extra two in order to manage if there is any additional spike or like read traffic which is getting spike or any indexes which were missed, that for to handle that kind of a scenarios. We have added extra two replicas, and also we used auto scaling feature with Postgres, wherein a replica gets added when there is a CPU surge happens. And this was the rollback trigger what we had, right? So the first major thing is a critical application failure, a functionality which is or a core functional flow is not working. That triggers a rollback. That means we have to roll back to the application. And severe data mismatch, as I said, when we had a severe data mismatch or during the validation phase, we had aborted the uh, further moving towards Postgres. We have trained back to Oracle and we corrected it and then come back. So this is one of the critical part. And performance degradation, like Postgres is unable to handle completely the production workload, even with uh, multiple replicas, or the issue goes beyond our hand. Obviously, that is also in rollback situation. And a replication issue, like final data was not propagating properly, even after reload, we had multiple issues. That is also an rollback scenario, or we have to trigger the rollback window. And again, application and function defects. So those are the common rollback triggers that we had defined along with the application team for a rollback path. Okay, so coming back to so this is all about the migrations we have done, and I'll just discuss about some of the issues and workaround which we have faced. Okay, uh, by default, when you start using DMS, right, the DMS by nature is single-threaded in nature. So even when you define the higher window like throughput, the higher commit ratios like 50,000 records per second or 60,000 records per second or per commit, even with a bigger table. So we had a bigger table, which was around 200 billion of record for last 6 months of data. So when we started loading with a default configuration, the load was going indefinitely. And also the thing is, uh, as I said, right, when once a full load complete, there will be an expiration of archival logs. So we do not have archival logs, then again we have to do a reload. So then we then we explored about the parallel loading features in AWS DMS. So this feature, what it does is we can segregate the tables based upon the primary key ranges. In our case, we segregated around 2 billion records for each ranges, and we created the task, and we had defined the threads per task. So we had given around 5 to 6 threads per task and start the loading. which was really helpful. That means the task which was running for 35 hours, you have got completed in 4 hours. Okay. So this is the example of the segregations which we have done with respect to the task. For example, so we used the ranges for the task. So we divided in millions. So this is a range we can use. These are all primary key ranges. This is a start range. That is, you can get the min range and max range from the Oracle. From the min range and max range, we divided equally with respect to the ranges, and we started the uh, parallel loading. So this is how we solve the slow loading issue with respect to the DMS. And the other thing is, once you start this, there will be high number of threads which is connecting to Oracle to pump the data to the DMS instance. So the thing is, as it's a rack server, right? We had faced the issue where the rack server CPU was going higher, so 95%, 96%, and obviously there are cases where we had uh, faced issues. We had to stop the DMS at our side to save the production. So what we did was that along with that, the rack, they had some of the read servers. So they have read replicas kind of a structure in the Oracle. So we started using them to avoid the production impact. On the other side, that is on the Oracle, on the Postgres side, when we started the parallel loading, we started seeing slowdown of the Aurora instance because it was not able to match with the faster threads. Like then we have to upscale the instance on the Aurora side. Initially, we had 4x large machine. We upscale the machine to 16x large to for this migration to handle, and also we used an we were seeing also IOPS throttling as well. So we used provisioned IOPS for the Aurora to manage this higher throughput of tasks. So you should take care when you start this parallel bounding. So it will be faster, but the resource consumption will be higher. As simple as that. Okay. Okay, and these are some of the lessons which we learned. Plan the parallel load from day one. So you get a table list based upon the size. These are the tables which have to go for a parallel load. Plan it from day one, not from the in between. We had a plan in between, so there was some delays in the migration. Sequence reset is a cutover step. Like it has to be done at the downtime window, not after. So when you do after, there is a possibility that the mismatch of sequence can happen and conflicts can happen. And also, as we had discussed multiple times, defer the foreign keys during the loading process and also the indexes and watch the CDC lags. So one important thing also I would like to mention, like when the table is going for a full load, after the full load completion, the DMS will not show a uh, proper metrics. After the full load, it has to go for a CDC, right? The CDC start time, right? It will take time. In certain cases, DMS will also get failed during that time. So just monitor closely the CDC lags as well. This can be seen in the DMS watchdog metrics. You can see what is the CDC lag per window, what is the apply rate. It's all clear. You can see there. And also hypercare is part of cutover. So you have to be very hyperactive during the cutover. Define everything. Don't run here and then during the cutover. Have a perfect plan for the cutover and respect the rollback asymmetry. So when you see there is a critical thing mentioned, prepare for the rollback immediately. Don't try to cover up things and mess up at the very last end. Okay. So that's all. You can ask your question. Yeah.
Okay, thank you so much, Kabilesh, for that insightful case study and breaking down those technical nuances so clearly. So to quickly sum up what Kabilesh just explained in simple words, moving off Oracle is not just copying tables. Most of the work goes into rewriting stored procedures and application queries as Postgres understands them, and also having a clear roadback plan gives everyone confidence before flipping the switch to production. Okay, thank you so much, Kabilesh. And we are now opening the floor for our Q&A session. To keep this interactive and engaging, you can type your questions in the chat, or else you can also unmute yourself directly, give us your name and ask Kabilesh your question directly.
while using the AI, right? So we tried the AI method as well, like rewriting the procedures and views. So it was correct to certain percentage, not complete correctness was done. We can say the correctness is equal to like 60 to 70%. As I said, it was not giving the exact results at what is intended with Oracle. So we had to make manual changes as well to the queries. And in certain cases, there were MVs, the metallized views. So that we had backported to the as a application logic itself, not in the database layer, to the application logic itself.
Thank you, Kabilesh, for your answer. And thank you, Ravi Vishnu, for your question. Anyone else? Yes, we have a question from Andramurthy for an on-premise or Oracle to Postgres migration, where the customer is not using any cloud platform. What is the preferred migration tool and approach, if any open source tool available?
Okay. So this customer was on premises system. Oracle was on premises. The target is in Aurora. So we as it's a AWS modernization project, right? We used direct link connecting to their on premises data center. We used it for customers which is completely on premises. You can use Aura to PG2 for the schema assessment and migration. And SCT as well. SCT as well works in the offline mode. You can download the package and you use it as a package in your on-premises for assessment and schema conversion to assess your system. Then,
And then we have one more question from Satish. When parallel load of 10 billion records on the target Postgres, will the Postgres able to handle it? And it was addressed by increasing the IQ peers and instance type change.
Yes, so when we started this parallel loading, we had issues at the Postgres side. That means the Postgres was not able to do the means we started seeing slowness when we started the task, right? The task getting slowed and it was waiting on the when we checked the active list in the Postgres side, we started seeing slowness. That means it was waiting on IO. So we had to increase the instance type so the memory get increased, the shared buffer get increased so that the processing get faster. And also we increased the IO. That is, we used a provisioned IO instance.
Okay. Thank you, Kabilesh. Thank you, Satish.
What is the cost of 4 TB Aurora database? So the cost is not based upon the size of data. It is per instance type what you use, and also the storage what you incur. Right, storage is dynamic, so it varies based upon the instance type. Okay, so to answer Naveen's question, right? So let's say we have the sequence which is completed in Oracle, let's say around 1900. So when we that was the stop point, the freeze point, wherein the no writes happens to the database. During that time, we get a sequence from the Oracle side, and we reset the sequence by adding a higher number in Postgres, let's say by 1,000 or by 2,000, so that the next sequence starts from 1,000 like 1200 something. So then we know that this is the Oracle writes that has happened post the cutover. Okay. So the critical point here is if there is a rollback, it should be a rollback before the Oracle writes start. So if the Oracle writes started and you want to roll back, it's a kind of a chaos situation. So it's a very minimal thing. That is the last thing you want to happen. So during that time, so we had discussed with the application team when these kind of situation happens, post the sequence number, the transaction replay has to be happened from the application side, and from the database side, we can take a CSV down from the particular sequence, the above sequence, and we can load it back to Oracle. This is the best thing which can do from the database side. And also to avoid the situation, we also had a smoke test window. Like after the sequence listed, the application team does a complete flow validation with respect to the functionality by creating some dummy insurance record or something. So ensure that it's all working fine. Post that, they started the live application traffic. So once after confirmation, they go for it. So thereby we avoid the rollback after the sequence is set. I hope I answered Navin's question.
Yes, thank you, Kabilesh. And we have one more question from Valinayakam Karthik. Can I take PG dump backup and restore to community Postgres?
Yes, is it from Oracle? Oracle does not support PG term backup.
No,
If it is
actually,
bit,
it is not Oracle. It is Adobe DB.
yeah,
From Adobe DB, we can take that PG dump backup and we can restore in that community version of the PostgreSQL. It
yeah,
is
it is
possible.
supported. It is
It is
possible
support.
because yeah, it is a logical backup, right? So it is possible. It is supported.
Okay, but actually, when I am seeing that it is that
See,
sys
the dump,
date and
no, the dump process is a logical dump, right? So the logical dump has a thing. It can lock the tables, right? When it's a live application. So that you have to take care.
no, actually, it is that when we are going for other database, then it is that six date and club and blog, everything will be same content will be moved to its other, right? So how it is possible to take that PG dump? If it is PG dump, then it will that taking that club and blog means cloud data and blog log data. So how it is moving that we can use that PG community version. So it is totally the data will be changed, right? Data
No,
types.
see, so you're asking question about moving from PG means AWS Aurora to community Postgres. Am I right?
Yes, other to community postgres. Before that migration is happening. Okay, so that migration, when I first question is that clog, C log and B log, the data type, how you migrate that? It is taken care by other or how it is going that?
No, no. So the CLOB and the BLOB table, right? Based upon the data type, let's say in Oracle. So if they're storing as text data, we choose a text data type in Postgres side. And if they're using JSON, we define the JSON or JSON B type. And based on that, based on the data type and the data which is stored actually stored in that, we chose the data type in Aurora side.
Can you explain more on this?
See, for
It is
Oracle,
actually C log, B log, and that sys date, and a lot of it is as per your session also. It is that we have lot of data types in Oracle. Okay, same it is when we are going for that Postgres. It is not there. If it is test also, we have that limit of limits and multiple things are there. And you are saying that it is a number, data engineer, sorry, mostly it will be going for numbers. Okay. So what I am asking, if it is that B log, C log, how you migrate that first point?
yeah, the
That
first point is
can
like
you explain that? Can you
yeah, to
explain
answer
that
your
a bit
first
more?
point, right? The CLOB data and the blob data, which is present in Oracle. So we get a sample of the table, that means the UAT environment. So we get a sample of the data. What is the actual data and the data type which is being used in Oracle? So for example, if it is a HTML format, so as it's a insurance client, right? So they had a lot of HTML data which is embedded in this CLOB data, that is large object data which is stored in Oracle. To manage the HTML data type in Oracle, we
Mm,
use a text data type in Postgres, text. So
mm,
text also, we have the tiny text, the larger text. So based upon the size, and also we got the maximum length of data from Oracle. Let's say
mm,
like what is the maximum length of data in Oracle? With that
mm,
maximum length of data, we added a 30% buffer, which I have explained in the DMS task creation also. 30% of higher size in Postgres to manage to migrate the data. So that is the LOB size, the large object size, which we defined in the DMS task to push the data from Oracle to Postgres.
Okay, so that's why I am asking that because of it is other it is that we have that length of that data type and everything will be increased, right? But in community Postgres, how we can manage that?
The community also follows the same, right? Because Postgres, Aurora Postgres is also a version of community. It is taken from the community and highly patched. The data types remains the same with both
Mm,
Aurora and the community version.
okay.
Yes, yes, thank you, Valinayakam Karthik, for your question, and thank you, Kabilesh, for your answer. Yes, so we need to wrap this on time. So uh, we shall close it here. A huge thank you to Kabilesh for sharing his expertise and practical lessons from the field. And thank you to all of you in our community for joining us and asking such great questions. Before we log off, here are a couple of quick reminders. So I will email the slide deck and the full recording link to your registered email early next week. And be sure to follow Mydbops on LinkedIn for our weekly technical blogs, database architecture insights, and updates on future events. And if you are planning a database migration or need expert support with your databases, reach out to us at info@mydbops.com or visit our website, mydbops.com. Thank you once again for your time today. We look forward to seeing you at Mydbops My Webinar 54. Have a great evening, everyone. Thank you.